Uh, Fine. So today's class is about guidelines for the relational database design. Okay. So as of now, if you go down the sequence is like first you design the ER diagrams with the help of which you can have an idea of what will be the different relations in the database, okay, or what will be the different tables in the database, and what will be the attributes in individual relations. The attributes will contain information about, or these are the characteristics of the entity set. So each entity in the entity set will be represented by the attributes present in that relation. Fine. Like we saw for the company database, you have the tables or the relations which are linked with the company, like employee, the project, the department, then the location, all those things. And each individual entity were having, suppose employee, you saw the attributes were name, then salary, address, phone number, employee ID, all those things. Okay. But how do you know that whether your design is proper? Because once you do the ER diagram, am I audible to all?
Yes, sir.
Is it audible? Hello. Mm, so once you design the database, then you in the process of designing the database, you also take care of the keys, etc., which are going to be the key, which attributes will be represented as the key attributes, and the relation among the attribute among the tables or the entities, how they are going to be represented, how they are mapped, how the ER diagram in total is mapped to relational model or in terms of the tables. Fine. But how you are confirm that whatever you did is proper? That means the design was proper, the ER diagram was proper, then the table that you built from the ER diagram was proper. How do you measure that? For that, there are some design principles which the relational database has to follow. Those are called guidelines. Guidelines for design principle. Okay. That means using those guidelines, you have to design the database. The guidelines are basically, yeah. Before that, there are two different types of design technique. If you can see the screen, one is bottom up, one is top down. If you are considering bottom up design of database, then what you do is that you collect individual attributes. Suppose I am collecting employee name and salary, then I see that this employee is getting this salary, so they can be put in a single table. Suppose I am collecting employee name and say department location. These two are somewhat unrelated. That means the employee is working in a department and the department is located in a location. But and department location is not part of the employee information. Okay, you can retrieve the data that where the employee is working in which location, but exactly saying the table should not contain the department location under the employee table. Fine. So these things you have to take care of, that which attribute will go into which relation, how you would measure that thing. So in bottom up design, you basically do this thing, that you collect individual attribute and group them, and you study that whether they can be grouped in a single relation or not. So this is very time taking process, and you have to do multiple groupings of individual attributes and see whether they are compatible with each other or not. So this process is hardly followed. Rather than that, the mostly followed approach is top-down design. That means you group multiple attributes which are somewhat linked with each other into a single relation, like employee name, age, salary, all those things you can group into a single relation. Similarly, department informations you can group into a single relation. Then you further see that whether the grouping is proper or not. This is a more better approach than the bottom up design. Okay. Now, how do you know that your things are proper, your design is proper? These are the four guidelines which should be followed. The yellow mark one. The first one is making sure that the semantics of the attributes is clear in the schema. Second one is reducing the redundant information in the tuples. Third is reducing the null values in the tuples. Fourth is disallowing the possibility of generation of spurious tuples. Tuples means you might have remember this is row. Okay, so there should be no row which contain redundant information. Less number of null values should be there in your table or in your database. Suppose in your database you have 5 different tables, like you saw in the case of company database. You have project, employee, department, those things. Okay, so under each relation, under each table, you should have minimal number of null values stored. As less as null value is better. Then final one is disallowing the possibility of generation of spurious tuple. This is somewhat different concept that we'll see. Okay, first thing is making sure that the semantics of the attribute is clear in the schema. What do you mean by that? Okay, so these things we'll discuss. This we cover. Yeah, the first is semantics of the relational attributes must be clear. Which semantics means what? What do you mean by semantics? It means rules. Okay, so the rules for designing the attributes or grouping the attributes must be in such a way that it should be linked with each other. That means it's better not to put the department location under employee table, because department location might be an attribute, but that is not directly related with employee. Okay, it is rather related with department. So better to put that attribute under department. Similarly, employee phone number you will not put in department table. Of course, the employee is working in the department, so department should keep the phone number of the employee, but that can be gathered when you combine the two relations, like we see in the case of foreign key. Using foreign key, you are getting the information from two different tables. Okay, so in that way you can retrieve the phone number of an employee who is working in department X, but the employee phone number need not be stored in the department table. So these are some kind of rules or semantics that should be followed uh, when you are sitting for designing the database. Okay, means grouping relevant attributes under an entity set. Got? Okay, so this was the first guideline, an easier one. Yeah, second one is reducing redundant information in the tuple. Redundant information means repeated information. That means as much as possible you try to design a database where the information are repeated very in very less amount. Okay, there should not be any repetition of the data in multiple tables. Suppose employee name or project name. Project name should be there in the project table. It should not be there in the employee table or in the department table. Okay, you should not repeat the same information again and again. For example, you see this one. Here you see the First employee is John B. Smith. Okay, he is working in department number 5. Department name is research. Similarly, second employee is also working in department number 5. Department name is research. Okay. So here you see what is getting repeated. As much as time you are storing the department number 5. Suppose there are 1, 2, 3, 4 employee of department number 5. So for that 4 rows, you are repeating the information of department name and department manager SSN. Yes or no? The department number 5 is having the name research and the manager ID is 333445555. So that is getting repeated in 4 rows. Instead of that, if you see that if you remove this 2 attribute from the relation, then also it will be fine. Okay, yes or no? In the previous example, in the last class, you might have seen that the employee was having department number. This D number was the foreign key, which was getting linked with the department number attribute of the department relation. These things were not there. But suppose a relation you are designing like this with this repetition of data, this is not a good design. Okay, these are repeatedly being stored in 4 different rows. Instead of that, you could have stored only the department number here. This column is allowed, but if you are storing these columns along with this table, then it is not a good design. Why we are saying not a good design? Because they may create anomalies. Anomaly means unusual situations, okay, or unwanted situations. In this case, there are 3 different types of anomalies possible: insertion anomaly, deletion anomalies, and modification anomalies. Okay, if you are having, remember this thing, that anomalies are occurring in database when you are having redundant data. Fine. Redundant data means those data which are repeatedly getting stored in multiple locations, which is not a sign of good design. So see the case of insertion anomaly. Suppose yeah, yeah. See the relation. The relation name is employee project with attribute employee number, project number, e name, p name, and number of hours. Okay, suppose this is an schema of a relation which has 5 1 2 3 4 6 different, sorry, 5 different attributes. Okay, now suppose a person has newly joined, an employee has newly joined. Here employee and project both are primary key. Say the combination of employee number and project number is the primary key. So what happens is that if an employee newly joins, okay, then what will be the, he is not allocated to any project yet. So how do you enter the data of the employee in the table? How do you enter the data of the employee if he has newly joined as not yet allocated to any project? What will be the row for that employee? Can you allocate any value to the project, null value, etc.? No, because that is part of the primary key. Okay, so null value cannot be inserted. So that causes a problem that uh, since the project number is not yet assigned and that is required for inserting the data into the table, that creates a problem. This is uh, an example of insertion anomaly. Because you are having problem, you cannot insert the data or the row of the employee into the table. Why? Because the project number is not actually related to the employee. It could have been avoided and it could have been created in a separate table or stored in a separate table. Okay. Uh, Fine. Similarly, say there is a new project being designed. None of the employees are assigned to the project yet. That information also you cannot store in this relation because the employee column will be blank. The data for the employee column will be blank. Getting my point? See the case here. Suppose here there is a new project being designed with project number as suppose 25. I want to insert 25 here and all other details here. But as yet there is no employee been allocated to the project. So what I will insert here? Null. But null is not accepted because this is a primary key. Okay, so this is the case of insertion anomaly where you cannot insert data because of this redundancy. Redundancy is in the sense of this p number. This p number is should not be a part of the employee relation. Okay. Then another case is deletion anomaly. Deletion anomaly is similarly this anomaly is generated when your what your data when you are deleting, then it causes other problems. Like see an example here, 30. Okay, suppose there is a project 30. Okay, so how many employees are working in this one? 9998877. 9998877. Okay, he is working in 10 too. Okay, 9876520 is working in this 30 and 20. 88866. Yeah, this one. Suppose the project number 20 is over. Okay, now I need to delete the project number 20. Then what will happen? This row will be deleted. This row will be deleted. Wherever 20 is there, it will be deleted. Fine. Suppose I am deleting this row particularly. This employee 88866, then 5555 will be deleted. Yes or no? Is there any other place where information about this employee is stored? Any other place? No. He is working only on project number 20. So if you delete this project, this employee will also be removed from the database, which is not actually the case. That means the project is over. He may be allocated to another project, but at the time when you are deleting this particular data about the employee will also be deleted. So this is called deletion anomaly. That means when you are because of this anomaly, if you are deleting some data, as a consequence you are also deleting some related data which is also getting deleted. That means this causes the loss of information due to this unrelevant uh, database design. So this particular design should be avoided. Fine. This is about your deletion anomaly. Here the example is given. When a project is deleted, it will result in deleting all the employees who work on that project. So alternatively, if an employee is the sole employee on a project, deleting that employee would result in deleting the corresponding project. Okay. Fine. Now, another thing is update anomaly. Update anomalies are the problems which arises because of redundancy when you update the data in some place but forget to update the data in some other places. Okay, say, yeah, suppose suppose I am changing the department name of department number 5 research to research and consultancy. Okay, the project name or the department name is changed to research and consultancy from research. So in this table, how many places I should do the changes? Here I should do the change. Here also I should do the change. Here also I should do the change. Here also I should do the change. So wherever you are having this data of research, that has to be changed. Okay, suppose I am changing in these two places, but I forgot to, or I could not find these two places. So these two places it will be research, these two places it will be research and consultancy. So when you are next time your query you are writing, you will write the details of the department name, research and consultancy. This two row will come up, this two row will not come up because this is still research. Yes or no? So what will happen is that you are getting wrong information. Part information is also wrong information. Okay, so out of 4 rows you are getting only 2 rows. That is a wrong information. Fine. So this arises because you had redundant data. You should have stored this in a separate table where only one row will be there with department number and department name, like in the previous examples that you have seen in the previous classes. uh, if you remember, or I should show all of you remember or not? I don't know in which part it was there. It's not here. Uh, yeah, you see here department name, department number, manager assistant, manager start date. So here only one row will be there with department number and the department name. There is no department name with this employee table. This is a good design. Fine. Here there is no repetition of data. But if you follow the previous today's class example, that relational design is quite a bad design because it has several repetitions. The department name and the department number is getting repeated at so many places. Okay, you see here department name, the same department is repeated. Department 4, wherever you are having department 4, all this department information will be repeated. This is also repeated. Fine. So these things are should be avoided. This is called update anomalies. When you update at few places, but you have data repeated in multiple places, that causes you update anomalies. So 3 anomalies arises out of your design problem, which is called insertion, deletion, and update anomaly. Fine. Any doubt in this? Anomalies? No. Okay. So the third guideline is null values, avoiding null values. So we discussed previously that null values occur mostly in 3 cases. One is attribute is not applicable or invalid. Like suppose there is the example was that yeah, it's given in the book also. The suppose the details about the employee is being kept. It's a foreign company, say American company. The details, one of the attribute in the employee table is visa status. So there are many foreign employees who are working in the American company. Say suppose there is an American employee also. For him, visa status will be nothing because he is the resident of America. So he don't have any visa. So what will be entering in the visa status attribute? Null. That means it is not applicable. Then attribute value unknown. I told that unknown means it may exist, but it has not been given. Say the case of salary. The person has not given his salary, details of the salary, so it will be unknown. Then value known to exist but unavailable. Okay, that means say landline number. So there may be landline number, but it is not given. So something like this, that there are three possibilities of occurrence of null values, but you try that as less as null value should be there in your relation. Okay, you should only keep those attributes with the entity set which are having any particular value. You should not store those kind of attributes where there may be more number of null values like this visa status, etc. It is not required to be stored as an attribute. If it is creating null values more often, then better not to use it. Fine. This is the third guideline. And the fourth one is generation of spurious tuple. This will be clear once you learn about the join operation. So for the time being, just uh, remember this as a guideline, that generation of spurious tuples means generation of wrong information. When you are suppose joining, like last class, some class before, we saw that what is the name of the employee who is working in research department. So how you are getting that? You are going to the department table, getting the department number from there. Then you are finding the number in the employee table. Wherever the number is present, that employee name you are giving. Okay, so in that way you are joining two different tables. So there will be some cases, if your design is bad, if your relational design is bad, then when you try to join two tables, you will get wrong tuples. That means those you will get some combination of information which is not at all present in any of the tuple, any of the relation. So that is called generation of spurious tuple. Generation of spurious tuple means when you join two different relations, you will get some row as a result which is not at all present in any of the relation. Okay, this thing will be clear once you go to the join concepts. Okay, for the timing, you just remember this is the fourth guideline. So so whenever you sit for designing a relational database from the or in the starting when you are doing the ER diagram, you should keep in mind that these four rules has to be followed. The first one is semantics of attributes. Okay, so the attributes in a entity should be chosen in a such a way that it is linked, or it is linked with other attributes of the entity. Fine. You should not store department name or department location under the employee table. So that is irrelevant. That is a bad design. Fine. Second is avoiding generation of null values. The null values should be as less as possible in the entire database. But it is not completely avoidable. You have to have null values in the database, but try to keep it as low as possible. Fine. The third one is, what is the third one? This one, null values in tuples. Yeah. Second one was rather this anomalies, avoiding storage of redundant information, because if you are having redundant information in the table or in the design, Then we'll be having insertion, update, and deletion anomalies. Fine. Then the fourth one is avoiding generation of query tuple. So your design should be in such a way that it should not be, when you link or join two or more tables, it should not give you wrong data. Fine. Any doubt up to now? That was a 5 marks question. Guidelines for a good database design. There are 4 points. Okay, no doubts. This is actually I am starting. This is a huge chapter, the most important chapter in the database management system. That is the relational database design and normalization. Okay, today we have started it. The first part is guidelines for database design. Fine. Then we gradually will shift over to the normalization part. So for normalization, this concept, this functional dependencies that is shown on the screen, that is hugely important along with the key concepts. Anyone saw the uh, YouTube link that I had shared? No, no one saw. Okay, I got disconnected because of this laptop issue. Yeah, so I was asking, how many of you have seen the link, YouTube link? Anybody
So didn't see the entire video, but
seen? No, I'm not saying about how many understood. How many of you have seen at least seeing the link?
yes, sir, I didn't see the entire video, but little it was talking about key, super key, and primary key.
So I also see.
Okay. Okay, fine. So where I was, yeah. And these are the guidelines. Now functional dependencies. Function dependencies are also a constants. These are also constants or set of rules that are applied on the database design to make it better. Without functional dependencies, the attributes of the database, the data in the database will not be proper. Okay, so this is a constant on the relation state, not on the relation schema. Okay, these are two different things. The concept is to be clearly understood. Functional dependency is a constant on the relation state. Okay, not on the relation schema. What do you mean by that? See, this says that suppose I am saying about primary key or super key or candidate key or foreign key, whatever. Those are constants on the relational schema. Okay, that means before you feed any data into the table, the constants are put in place. Okay, we will see in the experiments that if you have data in the relational table, afterwards you cannot create keys. First you have to create the key, then you have to insert the data, because the constants are always applied on the relational schema. So schema means the design. So first you create the table along with the constant, that is the key constants, then you insert the data. But the functional design, the functional dependency is the constant on the what relational state. That means you can get to know whether the constant exists or not from the inserted data. Okay, if it is violated, the data will also means the constant will not exist. Okay, this may happen that if three rows are suppose at a particular instant your database has, your relation has three rows. Okay, it is obeying the function dependency constant, it is obeying the primary key constant. The moment you try to insert uh, a null value into the primary key attribute, it will say that no, simply you cannot insert. Okay, that means that is not allowed. But if you insert a data which is violating the function dependency, it will be allowed. That means you can insert the data, but it will be the functional dependency will no longer hold. That means you can do it, you can violate the constraint and insert the data. But in case of the constraint on the relational schema, you cannot at all insert the data, which is violating the constraint. Fine. So this is one basic difference between constant on the relation schema and constant on the relation state. Okay. So what is functional dependency? It says that the set of attributes X functionally determines a set of attributes Y if the value of X determines a unique value for Y. Means it is represented database wise like this. For any two tuples, that means for any two row you select, suppose your relation has 1000 rows or 10 rows or 5 rows, any two rows you select. Okay, any two rows means say name them as T1 and T2. Say the two attributes about which you are talking about the function dependency. Suppose x and y are two attributes. So the value for x under tuple 1, if it is similar to the value for x under tuple 2, then value for y under tuple 1 and value for y under tuple 2 should be same. Better you see this example here. Here how many tuples are there? 4. How many attributes are there? 3. Suppose this is x attribute, teacher. Suppose this is y attribute, course. Now I am saying whether there is functional dependency existing between teacher and course or not. If this is x, this is y. So functional dependency is represented by x arrow y like this. Text hyphen text arrow course. Suppose I am seeing the functional dependency between teacher and course. Here, suppose this is T1 tuple, this is T2 tuple. What the rule says, if T1x equals to T2y, sorry, equals to T2x. Here, what is T1x? This is T1x because this is T1 row, this is x column. So T1 bracket x, that means this particular thing, this one. T1 bracket x is Smith, which is equals to T2 bracket x because this is x column. So this is equal, Smith equals to Smith, that means T1x equals to T2x. If this is the case, if T1x equals to T2x, then T1y equals to T2y. That means T1y equals to T2y. But here T1y is data structure, T2y is data management. These two are not same. So there is no functional dependency between teacher and course. It cannot be established. It is not possible. Teacher and course cannot be function dependent. Okay, but see the case of uh, text and course. Okay, say course and text. Suppose course is T1x. Suppose this is x column, this is y column. So what is T1x? Value of T1x. What will be the value of T1x? Anyone? That means no one is getting what I'm trying to say. Or what? What should I get? Should I repeat? Am I connected still or disconnected? No one is answering anything. If you cannot understand, then tell me. We can repeat. It's not a thing that I will go on and no one is listening or no one is understanding anything. Okay, let me repeat then. At least yes or no you can say. 23 people are connected. No one is.
Yes, sir.
The dependency is between attributes. I say that X functionally determines Y, or Y is dependent on X. Y is functionally dependent on X. That means it is the attribute X which can functionally determine Y. That means Y attribute get its value with reference to X attribute. Okay. So how the dependency is there? Now using this particular method, take any relation state. That means there may be 10 number of rows or 20 number of rows. If this thing holds, then you can say that the functional dependency exists between X and Y. So which thing hold? Now this one. If the value of X under two rows are same, then for the same two row, the value of Y should be same. You understand it like this. If the value of X for two row are same, then for the same two rows, the value of Y should also be same. I tried to skip all these things in between which are describing the functional dependency. Directly I came to the example so that you first get the things understood through the example. Then later you go for the details. Okay. So see, one column, this is my X column, say teacher is a X column, course is Y column. Okay. I am trying to figure out whether there is any functional dependency existing between teacher column and course column or not. So if it exists, I will write teacher hyphen course, or teacher arrow course is a valid functional dependency. So how do I ascertain that this is a valid functional dependency? Now using any two tuples, take any two tuples. Say I am taking these two tuples, first two tuples or first two rows. Tuple means rows. So T1 bracket X. T1 bracket X means this is X column. So T1 bracket teacher. What is the value? Smith. T2 means second row, suppose. T2 bracket teacher. What is the value? Smith. So as per the rule, T1x equals to T2x. Yes, this is valid. So the rule says that if T1x equals to T2x, then T1y should be equals to T2y. But here T1y is data structures. T2y is data management. These two are not same. So the function dependency does not exist between teacher and course. Got? Similarly, see the example of course and text. Suppose I am ascertaining whether there is functional dependency existing between course and text or not. So course is my X column, Y text is my Y column. Say this is T1, T2 row. T1 of course is what? Data structures. T2 of course is what? Data management. If T1x equals to, okay, here there is example. T1x is data structure. Suppose this is my T2. T2x is also data structure. So the first part is okay. T1x equals to T2x. Similarly, now I should say this one. T1y should be equals to T2y. That means T1 text should be equals to T2 text. But these are not same. So functional dependency again it's not existing. Got? Okay.
Yes, sir.
Now see the case of text and course. Between text and course, suppose this is X, this is Y. Okay. So tell me whether text and course will be functionally dependent or not.
No, sir.
text and course will be functionally dependent or not. Take any two row as example. Suppose this one is T1, this one is T2. T1 is equals to T2, no. T1 is equals to, suppose this is taken as T2, then also no. T2 taken as T2, then also no. But there is no repetition as long as the there is no repetition of T1. You cannot get whether there is repetition of Y or not. So this will hold. But if you say if you say text and teacher, bathroom is not present anywhere, so it is not repeated. So Y also you cannot determine. So you can say that text is functionally determining course. There is no problem. Similarly, course and teacher, between course and teacher, suppose this is X, this is Y. Data structures, here it is equals to data structure. So this is T1, this is T2, suppose T1 and T1x is equals to T2x, then T1y should have been equals to T2y, but it is not. So there cannot be functional dependency between course and teacher. Okay, but there can be. It is written, you see the above line, text and course may exist, because as of now, if you are considering these four rows, as of now, text and course are function dependent. Suppose at some point of time I insert a row where I will insert text as Martin. Okay, then I will insert here under course I will insert compiler. So it will be again invalid because Martin here is data management. Okay. So whenever I would have inserted Martin, I should have inserted data management. But if it is not there, that means the function dependency will not exist. Okay. Do I need to explain more, or this is everyone got? Tell me clearly, because based on this, next we will determine which will be the key attribute. Based on key attribute, functional dependency, sorry, the normalization, normal form 1, 2, 3, 4, 5, all will come up. Then you will not understood anything. It's up to you then. If you are not looking from here,
Sir,
I'm not also saying that.
sir,
Yeah.
sir, instead of Brown in the fourth row, instead of Brown, had it been Smith,
Sorry,
um,
sorry, sorry. Can you repeat what you are saying?
yes, sir.
Yeah. Sorry.
Sir, instead of Smith, Brown in the fourth row, had it been Smith, then can we say that teacher and course are functionally dependent because Smith has the course data structure, and in the fourth row as well, it would have been data structure, and the variation would be there in the text.
No, in that case, you are considering this as T1, this as T2. But in the same time, I can consider this was T1 and this as T2. Here also Smith is there. So you have to consider it for all the possible combinations. T1, T2 may be anything. Maybe this one, maybe this and this, maybe this and third. So if you are considering here, if you are writing Smith, and here it is Smith, this is data structure, this is data structure. For these two, this is fine. But when at the moment when I'm inserting this particular row, the functional dependency will no more hold. Because at this place, if I am inserting Smith, I must have inserted data structures in the course. But if I am inserting something else, the functional dependency will no longer be valid.
Fine, sir.
That's the concept. That means it is dependent is a constant on the relation state. So that is why it is written here text and course may exist, because by seeing these four rows you can say that text and course are functionally dependent. Text is functionally determining course because Bartram is nowhere else present. So you cannot compare any other row with this particular row. Okay, so similarly Martin is also assumed to be determining data management. That means text is determining course. If suppose at the fifth row I am inserting Martin compiler, here Martin, here compiler, so it will be invalid. So by seeing these four rows, now I am saying that functional dependency may exist. I am not saying that functional dependency exists. It is always may exist. At the point of time when I am inserting a row which is against the functional dependency between text and course, it will simply vanish. It will not exist. Suppose I am inserting Bartram, then data structures. Then I can say that yes, it still may exist because here Bartram is there, here data structure is there, which is equals to this and this. But suppose I am inserting Bartram and compilers, then again it will be invalid. Fine.
Okay, sir.
So this one is your functional dependency, which says that it's very simple. T1x, if T1x equals to T2x, then T1y must be T2y, or else it will be invalid. Okay, x and y may be any column, maybe this on this bit, or maybe combination of teacher and course with text. Okay, so that was your functional dependency. Now we go to the details. This is covered x and y in R specify constant on all relation instances of R. You see here on all relational instances, that means whatever number of row you insert, all the relational instances must be covered under this. If one row is inserted which is violating, then the functional dependency will no longer be true. Written as x arrow y, that means x is determining y. Social security number determines employee name. Yes or no? This is a valid thing. That means every social security number, social security number are always unique. Okay. So in that case, you can say that a primary key attribute functionally determines any combination of attributes. Getting my point? This is a very somewhat deep concept. Suppose I am saying that SSN is the primary key. It will not be repeated anywhere else in the any of the other rows, or it will be repeated. The value of SSN will never be repeated again. Yes or no? So you will find this kind of concept that Bartram is determining that structure. Suppose if at all you are inserting somewhere Bartram, then you have to see what is the value present here. But suppose I am not going to insert Bartram anywhere else in any of the row, then there is no worry because Bartram will never be repeated, and this may be repeated or may not be repeated. That is not a matter because T1x will never be equals to T2x. Okay or not? So there in that case I can say that the functional dependency will always exist between a key attribute and other attribute, because this key attribute, the value will never be repeated in any other row. Getting? So in that way, functional dependency will always exist when you are considering x as a primary key attribute or a primary key attribute as x. Okay. Similarly, project number is a primary key attribute. This is determining p name, p location. That will also be a true because this is a primary key attribute. This will never be repeated. You combine any attribute in this side, that is not a problem. You can combine all the attributes in the relation other than this, that will be valid. So that is why it is called DJ property. So that is why it is used to find the primary key of a relation. That we'll see how. The link I said is meant for that. That covered a lot of concepts That means our previous class concept and our next class concept. That's why I wanted you to see at least that how that will be used. Okay. So FD is a property of the attributes in the schema R. The constant must hold on every relation instant. If K is a key of R, then K function determines. See here, this point I am talking about. If K is a key of R, okay, suppose K is a key attribute, then K functionally determines all the attributes in R. That means you can combine all the attributes at the Y side. Okay, if X side is a key attribute, then it can determine all the attributes in the right side. This is the use. Actually, that video link that I said is based on this particular thing. That means if the right side, in the right side, if you are getting all the attributes, okay, then that functional dependency, from any functional dependency, if you are getting at the right side all the attributes, then that is a key attribute. Okay. In order to define the IDs, we need to understand the meaning of the attributes involved in the. Yeah, that's why these functional dependencies are determined by the database designer, who has a clear idea of what will be the content of the individual attributes. Okay, from that he decides a key attribute. So an FD is a property of the attributes in the schema R. Given the instance of a relation, all we can conclude is that FD may exist between certain attribute. Yeah, it may exist or may not exist, because there may be some data which will violate. Even one row can uh, negate the whole functional dependency concept among two attributes. Okay. Okay. Now, given this example, tell me among which attribute there can be functional dependencies. There is no solution to this. So there is no forward slide where I can show you. Just tell me. I am again.
B2, B and C.
This is very important. Based on this, your entire database concepts will be uh, stemmed. You have to have knowledge of this one, function dependencies, very clearly. Out of this only you are going to derive the key. Out of When you know the key, then only you can go for the normalization. After you do the normalization, then only you are having a properly built relation. Otherwise, there is no point. If you want to have 2, 3, 4 classes on this only, then I am ready. But this is utterly important. Any doubt is not allowed. You have to have clear idea on this. So give your view on this. Which two attribute will have functional dependency? Wait,
So C and B.
C and
B.
C and B will be yes. C and B will be having functional dependency between C1 is having B1, and nowhere else C1 is repeated. So this is allowed. C2 is repeated here. These two are equal means the value in B should be equal, because I am considering C with B. C arrow B. That means C function determines B. So if T1 and T2 are having same value under C, T1 and T2 must be having same value under B. So this is allowed. Now C4, B3. C4 is nowhere repeated else. So this is also allowed. So C and B functional dependency may exist. That is fine. Similarly, if I am saying B with A, B function determines A, whether this is valid or not. See here, suppose this is B1 determines A1. B1 is not repeated anywhere else, so this is allowed. Now come to B2. B2 is repeated here. So these two values should be equal, but this is not equal. So here the violation is there. So B and A don't exist. No need to go for further rows. If one place it is violated means Further, there is no need to see. Similarly, check between D and B, D1, D2, D3, D3. D1, D2 is single, so no need to worry. D3 is repeated, that means these two should be equal, but these are not equal, so no dependency. D3 between D and A, between D and A, D1, D2 is not repeated, no need to worry. D3, this should be repeated, no, these are not repeated, these are not same, so D and A also is not valid. Okay, now now if I see any other single one, B and D also is not possible, C and A, C and also is not possible. Suppose I am taking combinations now. Okay, suppose I am taking combinations now. Suppose BC determines A. Try to see this as one attribute, B and C as one attribute, and X side, this is A is Y side. So X side, this is B1 C1, whether it is repeated further, no. So this is no need to worry. B2 C2 is repeated, yes. So this value should be same, but this is again not same. So B and C cannot determine A. Clear? Like this you have to see. Any combination you have to see. Even you have to see three combinations. ABC. Suppose I am combining ABC. 3 determines D or not. ABC arrow D is valid or not. That I am determining. A1, B1, C1. Whether this is repeated? No. A1, B2, C2. Whether this is repeated? No. A2, B2, C2. Whether this is repeated again? No. This is also not repeated. So I can say that ABC determines D. For the time being, there is dependency among ABC and D. That I can say. If suppose another row comes up which has A1, B1, C1, D4, so functional dependency will not hold because A1, B1, C1 was here. It said that D value should be D1, but I am inserting D4 here. So again, it will not be valid. Okay. Now, like these combinations you have to find. Fine. So, any other thing? Any other doubt? You try examples on this, okay? So that you'll be more getting more idea on this. Next part is key, determining the key, that we'll see in the next class. Okay, so as of now, no doubt, right? Okay, let me take attendance. Okay, disconnecting.